Okay guys, so today what we're working on is secant lines and solving radical equations. So a secant line is a line that goes through, well, if you were to graph like a function, a secant line is a function that's going to go through two particular points on that function. So looking at our first problem here, we have find the equation of the secant line of the function f of x equals the cubed root of x plus 3 plus 4 over the interval -2 to 5. What this means is we're finding the secant line, and a secant line is going to be a straight line, and it's going to go through the points -2 and 5, and the points -2 and 5 are going to exist on that function. So -2 and 5, those are my x values because it's an interval. So what I have to do to find the equation of the secant line is plug in the -2 and plug in the 5 and find out what my y values are. And the equation of a secant line, since a secant line is a straight line, it's going to be y equals mx plus b. And to find the m, we have to find the slope. We have to find the rate of change. And the equation for the rate of change, which we've talked about before, it's going to be y2 minus y1 over x2 minus x1. And these numbers here, this -2 and this 5, this is going to be, well, I'll move this up. Yeah, move that up a tiny bit. What am I doing? Okay. The -2 and the 5, that is going to be our x1 and our x2. Those are both x values. And I need to plug them into this equation to find the corresponding y values. So I will do -2 first. So the cubed root of -2 plus 3 plus 4. -2 plus 3 is going to be 1, and the cubed root of 1 plus 4, cubed root of 1 is 1 plus 4 equals 5. That means my y1 is 5. My second y value is going to be when I plug in the second x value. So let's see, that would be the cubed root of 5 plus 3 plus 4. So 5 plus 3 is 8. So the cubed root of 8 plus 4. And the cubed root of 8 is going to be 2. So y2 is 6. So there we go. Y2 is 6. Y1 is 5. And now to find my m value, or my rate of change, what I have to do is plug these into the rate of change formula. So yeah. Okay. So I said my y2 was 6. My y1 was 5. It's y2 minus y1 over x2, which is 5, minus x1, which is -2. And that 5 minus -2, I'm going to turn that into 5 plus 2, because minus and negative is the same as plus. And I have 6 minus 1, or 6 minus 5 is 1. 5 plus 2 is 7, which means my rate of change here is 1/7. And that is my m value in my secant line. So I have y equals 1/7 x plus b. But I don't know what my b value is, because this isn't an equation yet, it's just 1/7 x plus b. So to figure out the b value, I can plug in one of my 2 points. So my 2 points, I'll go under here. My 2 points, I said my x1 was -2 and my y1 is 5, so there's a point. And when my x1 or my x2 was 5, my y2 was 6. So I can plug in either -2, 5 or 5, 6 to get my my equation of my secant line, or my b value. So I'll just go with the 5, 6, since they're both positive numbers. So my 6 is my y value equals 1/7 times 5 plus b. So 6 equals 5/7. Yeah, 1/7 times 5 is just 5/7. Oh, no, not even x. It's just 6 equals 5/7 plus b. And I subtract 5/7 from 6. I'm going to do that on my calculator. So I do 6 minus 5/7 is 5.29, but I'm just going to do math, enter, enter, and I get b equals, or as a fraction, I get 37/7 equals b, meaning that my secant line is, I don't really have much room. I'll come over right to the middle to write my equation, my secant line. My secant line here is going to be y equals 1/7 x, and I found that 1/7 using the rate of change formula, and then the b value is 37/7. So 1/7 x plus 37/7. And that is my secant line. And there we go. And I'm pretty sure the other secant lines it's having you find on here aren't going to have such nice fractions, and just leave it as the decimal. So we'll do the next one together as well. So this next one wants us to find the equation of the secant line. Oh, wait. Sorry, back to the first one real quick. So that means if I were to graph this line, 1/7 x plus 37/7, and also this function, the cubed root of x plus 3 plus 4, this line would intersect this function at these two x values. So yeah, that is what makes a secant line significant. Hold on. I just want to check something real quick for this next one. Oh, okay. That's weird. Okay. So yeah, if I were to graph these two lines, they would intersect at those 2 points, -2 and 5. So we want to find our secant line for -3 now, or not -3, -3 to 0, of the function f of x equals the square root of x squared minus x plus 1. So to do that, we are going to plug in our 2 points. So when -3 is the x value, so here's our x1 and our x2. So when -3 is the x value, that gives me the square root of -3 squared minus -3 plus 1. Let's see, -3 squared, I know that that's 9. And then minus -3, so that's just plus 3 plus 1. And 9 plus 3 is 12, plus 1 is 13. So this is the square root of 13. And that is my first y value. So that's my y1. My y2 is going to be, when I plug in 0, so that is the square root of 0 squared minus 0 plus 1. And I can just look at this and determine that is the square root of 1, because 0 minus 0 plus 1 is 1. And then the square root of 1, so y2 is just 1. So now I'm going to plug this into my equation. to determine my secant line, or my rate of change first. So I'm going to do y2, which is 1, minus y1, which is the square root of 13, over 0 minus negative 3. And again, that minus negative 3, that's just the same as plus 3. So I have 1 minus the square root of 13 over 3. And I'm going to type that on my calculator to find out what that comes out to. So 1 minus the square root of 13 is negative 2.606. And then I'm going to divide that by 3, because 0 plus 3 is just 3. And I get negative 0.869. We'll round that to 3 decimal places. So this means I have y equals, so this equals negative 0.869. So y equals negative 0.869 x plus b. We don't know our b value. So I can plug in one of my points now. I could either plug in 0, 1, or I could plug in negative 3 square root of 13. Either way, you're going to get the same answer, but 0, 1 is a lot simpler to work with, so I'm working with 0, 1. So I will plug it in. So that means I have 1 equals negative 0.869 times 0 plus b. Well, negative 0.869 times 0 is just 0. So that means 1 equals b. b equals 1. So let's see. That means when I write my equation, my secant line is going to be y equals negative 0.869 x plus, and b is 1, plus 1. Perfect. Negative 0.869 x plus 1 is my secant line that is going to go through this function at these 2 points. Perfect. So I want you guys to do these other 3 on your own. And these other 3, they were all lifted from the unit test, which obviously we're not going to do. But, so yeah, since they were lifted from the unit test, they should be fine. For number 5, you have to evaluate the cubed root. If you don't know how to do that, you're going to, on your graphing calculator, hit math, and then scroll down to the 4th option. So math and then 4, and then you're going to type in like whatever it is that you need to evaluate the cubed root of. So yeah, do that. And some of them might have both the m and the b value are weird decimals. That's fine. Do what works. Okay, so then there are these problems here. Solving for the variable x, solving our rational functions. And every single one of these 10 problems was lifted from the unit test. And that just goes to show like how much of this unit, like this is a pretty short unit in the first place. And we're cramming it into basically like 1 week, a week and a half maybe. But a lot of this unit was just solving these rational functions and had to do with these rational functions. So we will do 5 of them together, and then you'll do the other 5 on your own. So let's see. Number 6, I have negative 8 plus the cubed root of 5x minus 5 equals negative 3. So the first thing I want to do is get the radical by itself. I'm going to add 8 to both sides. So that gives me the cubed root of 5. I want a little more space, so I'm gonna shrink this a little bit. So the cube, dang it, okay. We'll take the pen size down a tiny bit too. The cubed root of 5x minus 5 equals 5. And now I have this. Cube root of 5x minus 5 equals 5. And I'm going to cube both sides. Since we're taking the cubed root, we want to get this x all by itself to solve for x, just like in any equation. And the next step is to cube everything. I can't cube things before. I have to get the radical all by itself before I can eliminate the radical. And to eliminate the radical, I basically just have to take this and cube it. I have to take that and cube it. So that means, well, this is going to cancel out, and all I'm left with on this side is 5x minus 5. And over here, I have 5 to the third power. 5 to the third power is 125. So I'm going to solve this now. So I can add 5 to both sides. That gives me 5x equals 130. And divide by 5 to get x equals 26. So my answer should be 26. There is one more step to these radical equations. What we have to do is plug that number back in and make sure that everything's true. So I'm going to come over here to do that. So I had negative 8 plus the cubed root of 5, and then I'm plugging in my variable, my 26, times 26 minus 5 equals negative 3. So let's see. 5 times 26 is 130, minus 5 is 125. So this is telling me negative 8 plus the cubed root of 125 equals negative 3. The cubed root of 125 is 5. So negative 8 plus 5 equals negative 3. And negative 8 plus 5 does equal negative 3. So that works. So x equals 26. That is our solution. The reason we have to check with these problems is because sometimes you'll do one, and once you plug it back in, plug whatever your solution is back in, it won't come out to a true statement. You'll get like 4 equals negative 3. And that's not true. 4 doesn't equal negative 3. So that's why we need to check. And I think there's like 1 or 2 on here that is going to come out to something weird, or where you're going to get no solution. Okay, so looking at this one, this next problem, I have the square root of 3x plus 12 equals x plus 8 to the 1/2 power. So to get rid of this square root, I'm going to square it. And I'm going to do the same thing over here. So once I do that, I got 3x plus 12 on this side because the square root and the square cancel out. But then I have x plus 8 to the 1/2 power to the second power. And 2 times 1/2, I just multiply the exponents together. 2 times 1/2 is just 1. So this is x plus 8 to the first power, which is just x plus 8. So 3x plus 12 equals x plus 8 because the exponents cancel themselves out. So now I'm going to solve this for x. I'll start by subtracting x from both sides. That gives me 2x plus 12 equals 8. And then I will subtract 12 from both sides to get 2x equals negative 4. And divide by 2 to get x equals negative 2. And once I plug this back in, hopefully it works. So let's see, the square root of 3 times negative 2 plus 12 equals negative 2 plus 8 to the 1/2 power. Okay, So 3 times negative 2 is negative 6. So this is the square root of negative 6 plus 12 equals negative 2 plus 8 is 6 equals 6 to the 1/2 power. Negative 6 plus 12 is 6. So this is the square root of 6. And then that 6 to the 1/2 power, as we learned earlier, we can rewrite that as the square root of 6. And I don't know what the square root of 6 is. It's going to be a decimal of some sort, but I know that the square root of 6, whatever it is equal to the square root of 6. So either way, this is true. So that means our answer is x minus 2. If we'd gotten something like the square root of 6 equals the square root of 5, that wouldn't be true, and there would be no solution. Okay, so x equals negative 2 on that one. On this next one, this one's going to be a bit different. So I have the square root of x minus 1 equals x minus 7. So what I'm going to do is I'm going to put that in parentheses and square it, and I'm going to put this in parentheses and square it. So the square root and the square cancel out over there. So I have x minus 1 equals, and over here, this is where it gets a bit different, because I have x minus 7 squared. And x minus 7 squared is not going to be x squared minus 49. No, it's going to be x minus 7 times x minus 7, and then I have to multiply it out. So I have to do x times x, which gives me x squared. I have to do x times negative 7, which gives me negative 7x. I have to do negative 7 times x, which gives me another negative 7x. And I have to do negative 7 times negative 7, which is positive 49. And I combine my like terms. So I got x squared minus 14x plus 49. So that means x minus 1 equals x squared minus 14x plus 49. So now I have to solve this equation. I'm going to set this equal to 0 so I can solve this quadratic, so I can factor this quadratic. And once I do that, I'm going to subtract x from both sides and add 1 to both sides. Gives me 0 equals x squared minus 15x dang it, okay, 15x plus 50, x squared minus 15x plus 50. And now I want to find two numbers that are going to multiply to be 50, but add up to be negative 15. So they're going to multiply to be 50 and add to be negative 15. And those two numbers, if you figure it out, are going to be negative 10 and negative 5. Because negative 10 times negative 5 is positive 50. Negative 10 minus 5 is negative 15. So we got x squared minus 10x minus 5x plus 50. Going to group between x squared and negative 10x. I can pull out an x, and I'm left with x minus 10. Between negative 5x and 50, I can pull out a negative 5, and I'm left with x minus 10, and that gives me x minus 5 times x minus 10 equals 0. So now, to solve for x, I need to set each of these equal to 0 independently. So if x minus 5 equals 0, that means x equals 5. And if x minus 10 equals 0, well, x is 10. So I got x equals 5 and x equals 10. But we need to check both these solutions, just like what we did with the last ones. So we need to check 5 and 10 and see which one works, if any. Or maybe both of them aren't going to work. So yeah, sometimes both will work, sometimes neither will work, sometimes only one will work. So let's see. I have the square root of 5 minus 1 equals 5 minus 7. And then over here, I'll do the square root of 10 minus 1 equals 10 minus 7. So let's see. 5 minus 1 is 4. So that will tell me the square root of 4 equals, and then 5 minus 7 is going to be negative 2. And here we have square root of 10, well, 10 minus 1 is 9. And it's telling me that should be equal to 3. The square root of 4 is 2. The square root of 9 is 3. So 3 equals 3, but 2 doesn't equal negative 2. So when I plugged in 5, it gave me an incorrect answer, but when I plugged in 10, it gave me a correct answer. So this means that x is only equal to 10. Yeah, x is only equal to 10 in this equation. X doesn't equal 5. So there we go. Okay. Then we have this problem here. This x plus 3 to the 2/3 equals 4. So I have this 2/3, and I know that I want to get rid of that 2/3. So what I'm going to do is I'm going to multiply it by the reciprocal to turn it into 1. So I want to turn this into x plus 3 to the first power somehow. So I'm going to multiply by the reciprocal, which is 3/2. So 2/3 times 3/2 is going to come out to 6/6, which is just 1. But since I took that to the 3/2 power, I have to take this to the 3/2 power as well. And when I do that, I'm going to get x plus 3 equals 4 to the 3/2. And remember that denominator becomes the root and the numerator becomes the exponent. So I'm going to rewrite this 4 to the 3/2 as the square root of 4 to the 3rd power. And again, we can either do 4 to the 3rd power first, or we can do the square root of 4 first. So I'm going to do the square root of 4 just because it's a little bit simpler. So I do the square root of 4, I get 2. So x plus 3 equals 2 to the 3rd power. I haven't evaluated that. I haven't used that exponent yet. And 2 to the 3rd power is 2 times 2 times 2, which is 8. So that's telling me x plus 3 equals 8. And all I have to do now is subtract 3 from both sides to get x equals 5. And I still have to plug this back in. So let's see. 5 plus 3 to the 2/3 power should equal 4. And 5 plus 3 is 8. So 8 to the 2/3 power should equal 4. I'm going to go ahead and rewrite this 8 to the 2/3 power as the cubed root of 8 squared. I'll do the cubed root first. So the cubed root of 8, I know that that is 2. So that's going to give me 2 squared, which should equal 4. And it does, because 2 squared equals 4. So 4 equals 4, therefore the answer is 5. All right, and number 10, and like number 10, hold on, I know that there's another one down here that's kind of like number 10. It's going to be weird. Yeah, number 15. So yeah, number 10, pay attention to this one because this one is going to be tricky. So I have the square root of x minus the square root of x plus 8 equals 8. I cannot start by squaring this. I can't, because these are two separate terms. This is like the square root of x minus the square root of x plus 8. So what I'm going to do first on this problem is I'm going to add the square root of x plus 8 to both sides. So that is going to give me the square root of x equals 8 plus the square root of x plus 8. And this square root, so now I have the square root of x on one side, and that is something I can square. So I'm going to square it to get rid of the square root. If I square this side, it doesn't get rid of the square root because we have two separate terms. But what I'm going to do over here, well, I know that this side is just x. And now I have x plus the square root of x plus 8 squared. I'm going to think of this square root of x plus 8, I'm going to replace that with something else. That square root of x plus 8, I'm just going to say, I'll give myself a new variable. This new variable will be n. And that equals the square root of x plus 8. So now, I just have this is going to be 8 plus n squared. And 8 plus n, I can square that. So if I do that, that is going to come out to, so I have 8 plus n times 8 plus n. So I do 8 times 8 gives me 64. 8 times n gives me 8n. N times 8 gives me 8n. And then n times n gives me n squared. And I'm going to combine my like terms. So this is going to be n squared plus 16n. Actually, no, I'll just leave it in the term in the order that it was already written. So 64 plus 16n plus n squared. And now I have to replace my n back in there, because I can't just put my n over there. I have to put my n back into here. So that gives me 64 plus 16, and then n is the square root of x plus 8, and then n squared, so plus n squared. But since it's the square root of x plus 8 squared, well, the square root and the square cancel out. So those two cancel out, and all I'm left with is that x plus 8. So I have 64 plus 16 square root of x plus 8 plus x plus 8. And I just combine my like terms one more time to give myself 64 plus 8 is going to be 72. So this is 72. That's a bad 7. 72 plus x plus 16 square root of x plus 8. And that is going to be what x equals. So 72 plus x plus 16 times the square root of x plus 8. So now, my next step is going to be to subtract x from both sides. So when I do that, I get 0 equals 72 plus 16 square root of x plus 8. Then I'm going to subtract 72 from both sides. So negative 72 equals 16 times the square root of x plus 8. And now I'm going to divide both sides by 16 to get that radical all by itself. So when I divide both sides by 16, so Negative 72 over 16 is going to come out to, let's see, I'm hitting my calculator here. So negative 4.5, which is the same as negative 9 over 2, equals the square root of x plus 8. So negative 9 halves equals the square root of x plus 8. So now we're getting somewhere. And now, since I have this radical all by itself on this side, I'm going to square both sides. So on this side, well, no, I'll leave that there. So the radical and the square are going to cancel out, and I'm left with x plus 8. And on this side, I have negative 9 squared is going to be positive 81. And 2 squared is going to be 4. So 81 over 4 equals x plus 8. And all I have to do now is subtract 8 from both sides, and so I have 81 fourths plus or minus 8. So 81 fourths minus 8, but 8 as a fraction over 4, since I want to make it into that. So 8 times 4 is 32. So that's going to be 32 fourths, because 32 fourths is just 8, equals, so 81 minus 32 is 49 fourths. And that equals x. X is 49 fourths. Not going to box that yet, because we're not positive yet, because we haven't tested it. Okay, so we'll plug in 49 fourths to our equation to check it. So I have the square root of 49 fourths minus the square root of 49 over 4 plus 8 equals 8. Okay, so the square root of 49 over 4. The square root of 49 is 7. The square root of 4 is 2. So that's just 7 halves. Minus, and then the square root of 49 fourths plus 8. We said 49 fourths plus 8 was 81 fourths earlier. So, and the square root of 81 fourths is going to be 9 halves, because the square root of 81 is 9. The square root of 2 is, or the square root of 4 is 2, and that should equal 8. So 7 halves minus 9 halves is negative 1. And this is why it's important to check your solutions. Because I plugged everything back in, I got negative 1 equals 8. Negative 1 doesn't equal 8. Therefore, x is not 49 fourths. There is no solution. There is no solution because negative 1 is not 8. And that is what you're going to have to do for number 15. I don't know if number 15 actually has an answer. I'm trying to think. I know that one of these isn't going to have a solution. Not sure which one though. But yeah, so there's no solution to that one. And then we had x equals 5. What was this one? Oh, x equals 10. Yeah, this one was x equals 10. X equals negative 2, and x equals 26. So, yeah, that is what you're going to have to do to solve these. So I want you guys to complete these 3 here on the first page, and then these 5 on the third page. And that will be all. Is that right? Yeah. And remember, when you cube a negative number, it stays a negative number. That's a tip for number 11 there. that's all. I'll put up an assignment or an assessment on Schoology. Keep up the good work, guys.